Hey guys, AP here, and today we are going to be continuing our Lightweight Java game library series. In this tutorial, we're actually going to be finishing up our math classes to actually be useful for what we're going to do in the future tutorials. So what we have right now is we have all these methods in the matrix class, and that's good and all, but we kind of left the vector classes to their own. We have ourselves like a little temporary add. But this is not how we're going to do adding in vectors, so we're actually just going to get rid of this and actually start doing the actual methods. So similarly to how we did the matrix methods, we are going to do static methods that take in, like for instance, a multiplication one that take in one matrix and another matrix, but for vectors. And we're going to do those for all the signs. So we have about 4 signs that we have to do the basic math stuff. We have add, subtract, multiply, and divide. And those are kind of self-explanatory. Adding vectors is we add all. Adding vectors is where we add all the x, y's, and z's to each other. Subtracting them, multiplying them, dividing them. So we can do that by just making one method and then copying, pasting, and just changing the sign. So the first method we're going to make is the adding one. So public static, and it's going to return a vector 3f, similarly to our matrix class, as you can see. And then we're going to say add, and then we're going to take in 2 vectors. So we're going to take in one vector, just call this vector 1, and we're going to take in another vector and call this vector 2. And then we need to actually return a vector that's adding. Now, since these are vectors and they don't really have as much data in the vector as it is, because this has 16 points, so we have to set all these points to whatever it is. We can actually just use one lines here, and we can just say return new matrix new vector 3f, and then we can just set those to the x and y's, or the x, y, z's added together. So to actually start this off, we need to get the x of the first vector, so vector 1 dot get x, and then we need to add that with the x of the second vector. And then so on for the other 2 values. So vector 2 dot get x, and then we can just copy this and change a few things. Most of this tutorial is going to be copying and pasting, because they're all quite similar until we get to the last couple methods, which they're not similar. So now that we have that, we need to say get y for these, and then get z for these. So that is going to be like the basic sign mathematics, so adding, subtracting, all that, and it's not really that complicated to understand, because adding, subtracting, and all that has been done since the first couple years of school, so like 1st or 2nd grade, maybe even kindergarten if you grew up in a special one. So the next things we gotta do is we gotta get all the other signs in, so subtracting, multiplication, and division. Mostly just the subtraction and multiplication. There's some times when we need to divide, but multiplicate. Why am I having such a time? Multiply. I just had like a poop. I don't know why. So, and then divide. So there we go. And now all we have to do is change the signs. So there we go. Multiply, 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 and divide. Now you could add another method, which basically instead of using a vector, it uses one number, and then that one number is spread across all 3 of them. But for right now, I'm just gonna, if I want to do that, I'm just gonna say vector 3f and then put that value 3 times. This is a pretty universal method, because you can create a vector basically using anything, with anything float-wise, x, y, z. And yeah, so we got the basic mathematics down. Now we're going into some vector maths. So what vector maths is basically math vectors. Pretty self-explanatory, and it's actually going to be useful for us in the future tutorials when we get into light, when we get into all the normal stuff. It's just going to be pretty good. So we have all this basic math, and now we're going to add another method, and we're going to call this, it's not going to return a vector, it's going to return, it's going to return, what is it called, a float, because this is going to be a number, and it's going to be the length of the vector. And also we need to provide a vector for this, so we can just say 3f vector, and then we can start adding our math in. So what a length method does, it's basically returns how long a vector is based off of 0, where the origin is 0, 0, 0, which is useful for normalization, but I'll get to that in the next method. So how we do this is basically solving for Pythagorean theorem. Now, if you don't know what Pythagorean theorem is, it's basically saying that a squared plus b squared is equal to c squared on right triangles, and you can get all the sorts of things. It's just basic geometry that you taken in high school. So if you're not at that part, if you're just a middle schooler, first of all, get off my video. Just kidding, don't get off my video, that's a joke. Please don't get off my videos, and please don't dislike it. But basically you'll understand it once you get older if you're a middle schooler. Anyways, we are going to actually put that in there, and since this is actually a 3D vector, because it's x, y, z, we're just going to add like another z squared. So if you remember how to solve for c, all you have to do is return the math, the square root, so math.square root, and then you need the x squared plus the y squared, and then for this case the c squared. So vector dot get x times vector dot get x, and then we're going to add vector dot get y times vector dot get y, and then we need to add the 3D coordinate vector dot get z, and then multiply that vector by get z, so vector get z. And that is how we get the length. Oh, and then we all have to cast this to float, so float, and there we go. So this is the length of the vector based off the 0, 0, 0 origin, and yeah, so after we get this vector, we need to actually use that in normalization. Like I said before, this is useful for normalization. And yeah, so public static, and this is going to return another vector 3f, and we're going to call this normalize, and it's going to take the vector we provide in, so vector 3f, and it's going to normalize it. And what that basically means is makes it a unit vector, which means it has a length of 1. So this is actually useful for direction. So say that you want to point leftwards, or you have, so say you want to actually find the direction of a vector, but you only have just a vector that's pretty long and you can't really do much with it. You can normalize it, and it will always stay at a length of 1, and you'll figure out the direction. And so that's pretty easy. All we have to do is we have to take the current xyz and divide it by its length, which basically means that the longest, that means that you can basically make it a unit vector. So this divide vector 3f function is actually going to help us here, because we can just do float length, or len, is going to be equal to vector 3f dot length of the vector we provided, and then we can do or return vector 3f dot divide the current vector that we have, which is the vector we provided, and divided by another vector, which, like I said before, is just going to be length, but since we don't have the ability to do that, we can just say new vector 3f length, length, and length. So now that we have that, we can actually do one more function. There's one more function for this, and it's going to be called the dot product. Now the dot product basically stands for how much is a vector pointing with another vector. So if it's positive, that means it's actually pretty close to pointing in the same direction. If it's 0, that means it's perpendicular to it. And if it's negative, that means it's going to be pointing away from it. So we can do that in another static method. So it's going to return another float because we're using like how much of it is actually pointing. And then we need to say dot. And then we need to provide two vectors. One, we're just going to call it 1 and 2 like we did up here. So we can actually copy and paste this. So copy and paste that. And then here's how you do a dot product. So we can actually return this straight up, and we can say return vector1.getX times vector2.getX plus and then the y and z of the. So we can copy this plus copy that, and then change this to y and z. And this will get the dot product. Now there's also a special a way of doing this is if you normalize the vectors before you do this, you can actually get a pretty simple -1 if it's pointing in the opposite direction, 1 if it's pointing in the same direction, and 0 if it's perpendicular. And that is useful for light. So the dot product is actually useful. We're going to be using it in our shaders. So it's pretty good. So that is actually going to be it for all of these function classes or methods that we actually implement ourselves. And so now for finishing up our math classes, we need to add a few more things. So if we go into our source and we say generate hash code and equals, and then do all our fields, which is the x and y and z, we'll get two functions right here, one that says hash code and one that says equals. So I'm just going to go through these one by one. Hash code is used for hash maps, and this basically is a way of getting a separate integer for the same values. So that means you should be able to know which values you can be able to get. Say you have different classes but the same values. These should return the same thing. It's useful in hash maps because the hash map calls it and it's seeing whether or not the values are the same and whether or not you can compare them or not. And then equals allows you to see if another object is able to equal this vector object. So we have a couple of statements seeing like some edge cases, like if it's actually the same thing. So if this is equal to object, return true. If the object's not even there, return false. If it's not even the same class, return false. And then it actually gets into the meat of it. You also see float.float2 int bits, and that's basically for edge cases. That means that just in case that the x, y, and z is not actually a way of, and that is actually not a number, you can actually just say int bits and it'll return like 0. Yeah, that's basically it. So we're going to continue on to our vector2f class, which is very similar, by the way. It's only it's the same thing, but basically without the z. So we're going into our math class, math2f. We can actually just copy and paste this huge portion right here. We could just say right here, and we could just get rid of all the z's. So as you can see, z is not available. So we could just poof, z, poof, z, poof. Oh, and this has to be vector2f. I was like, why is that an error? So we have vector2f. Let's see what we have to change to. So we changed that, and now we just got to get rid of all these z's. So boom, boom, boom. Basically, wherever you see vector2 or 3f, replace it with vector 2f. So just change that. All these vector 2f's. I know this is just a lot of copying and pasting, but like I said before, that's what this entire tutorial is going to be. So now that we have all vector 2f's, just get rid of the z's. So z's gone, z's gone, z's gone. Oh, vector 3f's, I see those here. Boom, 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 boom. I'm pressing Control B. So vector 2f, vector 2f. Okay, all these are good. Alright, so get rid of these z's, get rid of these z's, get rid of this one, and then get rid of these z's. So there we go. Very simple conversion to vector 2f, and now we should be able to use these vector classes for actual purposes, like moving objects and moving a camera, which we're going to do in the next tutorial. So we can actually close this out. But before we're done, I'm going to do the same thing that we did for the hash code and the equals for the matrix 4f, and I'm going to organize this to do it right here. And this is just a way of just making it all complete. So now if we look at this, you should be able to see elements is now being turned into a hash code equals. So now with all the math classes complete, or at least to a state where we can actually do stuff with it, let's actually be able to move our object correctly instead of having to do that weird method we had to do. So let's do this in the camera, because the camera is going to be the one that's moving most of the time. So right here we can just say public void update, and then right here we can say if input.is key down. We can do glfw dot, let's do a, so key a, and import glfw. So if the key is down, we are going to add a certain thing. Let's make that a variable called move speed. So float move speed. So now with that out of the way, we can say position, because we're returning a new vector 3f, is equal to vector 3f dot add the first vector, which is going to be our position, and then vector 2f, which is going to be a new vector 3f, where the x is going to be either negative or positive depending on the key. So since a is going to the left, that is negative, we're going to say negative move speed. And then the rest are going to be 0, 0, because why not? And so we're going to copy this 3 more times for the rest of the, actually 5 more times, because we have the up and down too. So say we have D, which is going to the right. We're going to change that just to positive move speed. And now we're going to do W and S. So W is moving forward. That means going negative in the Z axis. So change that to 0 and change this to move speed. Going S is going backwards. So that's positive in the Z axis. So similarly to W, just do that, but for positive move speed. And then for the up and down, I'm just going to do it similar to Minecraft controls, space for up and shift for down. So key space, and then we have to do left shift. Left shift. Is it left shift or L shift? No, it's left shift. Okay. So then we need to say space is positive in the Y, so change this to positive move speed. There we go, just do that. And then we need to change this to negative move speed in the y-axis. So now with some input in here, and now that we actually can do some adding with our vectors, let's actually update our camera to move. So now if we go to our update, before we actually do any of that, actually we don't even need this anymore, since we're not really testing those features out anymore because we know they work. So camera.update. So now if we actually run this, we should get camera movement. In which case we don't. What did I do wrong? I forgot to set move speed. Just set that to whatever value you want. Sorry about that. That's just a silly error on me. So now if we set that move speed, we should be able to move our camera, and we can. So I'm able to move the camera in a somewhat simple way, but it's still better than nothing. We're still able to move our camera around. Rotation's not there yet. I bet we can rotate it with the arrow keys, but for right now this is pretty good. So I hope you enjoyed this tutorial. This is the end of the tutorial, by the way. In the next tutorial we should be able to we should be going over camera movement and all of that, and so yeah, I will see you guys in the next tutorial. If you like this tutorial, please leave a like. If you want to see more of these tutorials, make sure to subscribe, and I'll see you guys in the next tutorial. Like I said, bye.